Good afternoon, everybody, and welcome to the ABB TechTalks for Marine. Keep your vessel sailing with remote support. My name is Anto, and I'm running the digital service globally here at ABB Marine Ports. So some practicalities before we get started. Please note that this webinar is being recorded, and you will be able to access the recording within the next few days. A question and answer session will follow the presentation. So if you would like to ask our speakers a question during the presentations, please click on the chat icon at the bottom of the screen and type questions in the chat panel that will open on the right-hand side. We will address as many questions as we can during the Q&A session. Our panelists today are Stian Brastad and Jarkko Tiainen. Stian and Jarkko, could you kindly introduce yourselves?
Yes, hello. Stian Brastad here. I'm the Global Manager for Smart Asset Management in ABB Marine and Ports.
Good morning and afternoon to everybody, and thank you for joining the webinar today. My name is Jarkko Tiainen, and I'm running the global sales of digital services within the ABB Marine and Ports and based in Helsinki, Finland.
Thank you, Stian and Jarkko. So our four main offering portfolios belonging to digital service are digital transformation projects, cybersecurity, advisory solutions, and smart asset management. Our main focus today will be on collaborative operations and remote services and support. So, without further delay, let's get started on today's agenda, and welcome everybody from my side.
Okay, thank you, Anto. So, agenda for today's webinar. First, how ABB is supporting the full scope of ABB systems on board vessels from our collaborative operation centers. Then, giving an introduction to our capabilities towards onboard system monitoring, equipment diagnostics, and maintenance services. After that, we're going to show a few real case examples on how we are utilizing our remote diagnostic system to assist customers and vessels in operations. Then how to best support vessels remotely. And after that, a Q&A session as Anto explained. Over to Jarkko.
Thank you, Stian. So how do we take care of the full scope of ABB systems? We at ABB believe in collaborative operations, where through our digital tools and processes, the data captured on board the vessel is shared in close to real time, both to ABB domain experts at the collaborative operation centers, as well as to the customer onshore fleet centers, or basically to any fleet manager, superintendent with a computer where you can access our online tools. This allows both the operational experts on board and onshore, as well as the ABB domain experts jointly collaborate on the real data, having the real situational understanding and thereby maximizing the asset uptime and operations. So with collaborative operation approach, decisions are based on the most recent data, communication is clear, streamlined, and transparent. At the core of the collaborative operation centers are the 8 ABB collaborative operation centers distributed around the globe, which are supported by marine service units in 26 countries and over 40 locations globally. So Stian, could you explain further in detail how the collaborative operations functions?
Absolutely. So first, a bit information on how we are operating our day-to-day activities. So Our collaborative operation centers are running our 24/7 care service and also acts as a single point of contact for all technical inquiries coming in from our customers. So in these 8 centers, we are responsible for providing technical support and remote support services to our end customers. The setup is so that we have regional centers, 3 centers, in fact, providing the 24/7 care support, and we have 5 other centers with specific competences towards individual products or systems. The setups allows us to give quick and good response time, and also it gives direct access to our technical engineers. So when customers are either contacting us by phone or by email, they immediately get access to our technical domain experts, which typically has a background from service or commissioning with a very high level of competences towards our ABB systems and our products. In addition to that, we use distributed systems, meaning that we are all working out from the same case management system, which enables us to have a documented approach to every case that we are handling. If it's a simple case or if it's a more complicated troubleshooting case, we are all following the same processes, and every step of the process is well documented so that we have a good audit trail of all the activities done towards any specific case. As mentioned by Jarkko, we have 8 collaborative operation centers now spread across the world. A bit different functionality. We have the 3 centers, a center in US, Norway, and Singapore, which acts as our L1 support centers, meaning that they are always participating in this single point of contact responsibilities. We have a seamless handover in between these centers, so that typically we will have daytime support out from Norway during CET office hours, and then we hand it over to the US center, which then takes over ongoing cases and receives new cases from our customers, which again hands it over to Singapore. Then on the level 2 side, we have these more domain specific centers. To give you a few examples, out from the Collaborative Operations Center in Finland, we are supporting the Assipod product. Out from the center in Italy, our automation and control products. Out from Netherlands, we have our advisory system, our Octopus system. And then in addition to that, we have China and Russia, which acts specifically towards Russian-speaking and Chinese-speaking customers. In addition to level 1 and level 2, we are also from time to time or case to case also receiving support from our ABB factories, our third-party suppliers, our local service centers, our warranty departments, R&D units, and also engineering, should that be required. To give you a brief overview of how we are operating, we've seen now during the last years an increasing amount of cases coming into our L1 centers. Cases originate from all different types of vessels, all vessel segments, with the ABB equipment on board. Also notably here is the increase in March 2020, which to some extent can be related to the ongoing situation and with the travel restrictions that we have seen for the past few months. So we've seen, if you compare, for example, March 2020 towards March 2019 or 18, a 20 to 25% increase in amount of cases. This is also one way of operating, is that due to these travel restrictions, we've also seen that some of our service engineers are also now contributing into strengthening the team and enabling us to continue business as usual and making sure that we deliver response times and the quality of support accordingly also. We have also set up an interactive poll. Hopefully that appears in your right menu in the section now. So the question is that we would like to hear your opinion on is, are you or your organization utilizing tech support or remote support services? not only from ABB, but it's also interesting to understand if you're using it towards other OEMs and at what frequency you are typically utilizing tech support or remote support services on. So timer here, so quite short time to answer this question. So not many answers. Maybe the time was a bit short, but at least some of you are experienced with utilizing tech support or remote support services. But most of the participants looks like they did not have time to answer. So I guess we will move on to the next slide. And that means over to you, Jarkko.
Thank you, Stian. So, how does the onboard system monitoring and remote diagnostic system and services function? So at the core of the remote diagnostic system is an industrial PC, which is physically on board the vessel, connected to the various ABB equipment, maybe motors, generators, switchboards, drives, azipods, turbochargers, and it's collecting data from this equipment, making the data available locally, normally in the engine control room for the onboard crew, for troubleshooting and inspection of the equipment. But the data can be also replicated through ABB cloud infrastructure, both to ABB collaboration centers globally, as well as to the customers' lead centers or operation centers. Stian, could you explain more in detail on which equipment do we connect and how does it really function?
Absolutely. I can also mention that in addition to the features that you see on the slide here, RDS platform also supports data sharing capabilities, which means we're enabling also onboard data sharing from the RDS platform over OPC UA towards third-party systems. The RDS system consists of different modules. I will jump to the next slide now just to give you some insights to that. So basically, the RDS system consists of different modules, which makes the systems fully customizable and very flexible. It's also suitable for full scope vessels with large power and propulsion systems, but equally it's also suitable for smaller systems or even single products if there is a wish to monitor, for example, a single drive or a single machine on board a vessel. The system is separated into different diagnostic modules. We have a wide variety of different diagnostic solutions, ranging from solutions for rotating machines, where we have both online and offline solutions that supports and enable condition monitoring services. For the power systems or switchboard systems, also we have connectivity towards both the breaker systems and also the protection relays. For those of you familiar with the product names, we have also listed them here. The new protection relay series called Relion, but also the old protection relay series, the REMREF 5 series relays. In addition to that, we have a temperature monitoring system that replaces the need or requirement for IR temperature or thermographic imaging of switchboards. Instead, it's an online system where the RDS system is continuously collecting temperature information from various hotspots, busbar connections, cable connections, tulip connections, and so on in the breaker system. On the propulsion side, as you can see here, we have a supported solution towards both low voltage frequency converters, medium voltage frequency converters, and also the control systems, the propulsion control systems, the drilling control systems, and so on is also supported, and data can be collected from those systems. In addition to that, drilling systems largely consisting of frequency converters and different type of controllers also being monitored by the RDS system. Of course, for the Azipod product family, we are supporting condition monitoring services and general data collection from the wide range of Azipod products that we are delivering, and also on the power side, meaning energy storage system, diesel management systems, and so on, is also possible to integrate towards the RDS system. Give you a few examples. On the slide now, we see on the left side the onboard user interface. Typically, this is the user interface that is located in the ECR and is meant for the engineers and electricians working in the engine control room to make sure that they have access to the correct information should a critical incident or any type of incident occur. It consists of three main sections. On the left-hand side, there is a KPI section. The RDS system also runs quite sophisticated edge calculations, and KPIs output from those calculations are displayed to indicate, for example, status of a closed cooling circuit of a frequency converter or a condition of a rotating machine. Based on the vibration data that we are collecting, these KPIs are made available for the onboard crew. On the middle section, you have a very detailed event list where you have access to information in the resolution of milliseconds. So much more detailed than, for example, your traditional automation system or HMI system. In addition to displaying any kind of alarm, event, fault, or even parameter changes that occurs inside any of the monitored equipment, it also gives the operators or the crew on board access to troubleshooting advice. So every fault that can occur is always linked with hints for rectification, what can be done to rectify the fault or the problem that has occurred. And also it indicates possible causes. To give you an example here, if again a frequency converter trips out on a overcurrent fault, for example, it will immediately give the electrician or the engineers on board access to information on where to start the troubleshooting process. On the right-hand side, you have a trending interface which enables the operators to access real-time data, set up specific trends, monitoring situations where that is required, or also reviewing historical information, historical trending information. With the cloud connectivity, we're also trying to replicate at least the critical data that is made available on board also for the onshore personnel. So this is something you see an example of on the right-hand side, accessible through our fleet portal. Here you can see the same type of KPIs that is seen on board, and you also have access to the same type of trending information and analytics in our fleet portal. To give you some real case examples how we are working with RDS in real life, we have selected a few quite recent cases that we wanted just to show you how we are utilizing the remote diagnostic system and how the customers are also utilizing the remote diagnostic system. So first, case that occurred in late February 2020. This is from a LNG tanker experiencing a partial trip of the propulsion system. So what is interesting here is if you look at the top right-hand side image, so this is what we call a critical trip notification. This is available for all the technical support engineers working out from our collaborative operation centers, and it's also a service that is available for the end customer. So this is basically a SMS and email notification sent to all the involved parties if the system on board detects a critical trip. We have quite advanced functionality implemented on board to filter out, let's say, non-critical events versus critical events. Some key information already stated in the notification, as you can see here, some operating parameters from the system being monitored. What was the RPM, what was the power, what was the torque, and what was the DC voltage at the time the fault occurred. This enables the technical support engineers to immediately see that, hey, this is most likely a real case. The frequency converter was in running condition. We should act immediately and start analyzing the data. At the same time as this SMS or the critical trip notification is sent, there is also a batch of data being automatically exported from the RDS system on board to the ABB cloud. This contains of data, typically 1 hour before the incident happened and up to 10 minutes after the incident happened, meaning that the technical support engineers will almost immediately have access to high resolution data that they can analyze to pinpoint a fault coming in from any of the RDS systems. So in this case, critical trip notification was sent. The duty engineer analyzed available data based on the event list, the data loggers that the system is collected. It immediately pointed towards a faulty power supply or gate unit power supply in a medium voltage frequency converter. ABB duty engineers sent detailed troubleshooting instructions to the crew on board. Typically, it's step-by-step procedures, which starts on how to make the system safe, to work on, isolate the system, and so on, to very detailed instructions on where to measure, how to measure, and so on. In this case, a relatively simple fault, a power supply suspected being faulty, measure input voltage, output voltage. If it doesn't correspond to the nominal values, then replace the power supply. This was exactly what happened, and crew found the faulty component and replaced it with spare, and the vessel continued in normal operation. Second case from a mega yacht, a breaker issued, a bit different process here as you might see. So here it was the crew on board the mega yacht that contacted the 24/7 care duty engineer on April 12th this year. They reported issues with the starboard propulsion circuit breaker. They were unable to close the propulsion breaker upon starting the system. Here we connected to the vessel via remote link, analyzed again the available data. The fault was immediately pointing towards the circuit breaker auxiliary signals, so status signals going in between the frequency converter and the breaker itself. Again, detailed instructions were given via chat functionality to the crew on board, and they were able to detect a faulty coil on the breaker or auxiliary contact. Faulty breaker was replaced with spare breaker, and the vessel could continue with its normal operation, and the breaker is or will be sent for repairs. So this is just to give you insight to how we are on a daily basis or weekly basis working with the remote diagnostic system out from our collaborative operation centers. I'll hand it over to Jarkko again now. So Jarkko.
Ian, we realized that the poll went so quickly the last time, so we will try to do it again. So let's see if we can get excellent. So we have the question on the right hand side of the screen again. So please, if you could check and answer one of the options. So are you or your organization utilizing technical support or remote support services? So you have few options: daily, weekly, monthly. No, but we are considering an not applicable option available. And while you have perhaps already answered on the poll, you also have the chat functionality where you can post questions. Would any of those arise during the presentations? We already have few coming in, so we will have a nice Q&A session coming shortly. So 3 seconds time to answer, and let's see if we can get the results to the screen as well. Excellent. So now we got quite a few answers, which is nice. So we see that actually for the majority, they are not yet using or it is not applicable. But then we actually have quite a few on monthly basis. Ian, how does this relate to your understanding of the customer base?
I think this correlates well to what we see from our customers with the ABB installed base on board. I mean, we have more than 4,000 vessels sailing around the world with ABB equipment on board, and I think it's quite representative for the amount of inquiries that we are getting into our collaborative operation centers.
Indeed. Excellent. So then we'll continue to the last section, how to best support vessels remotely. So we have bundled 3 different layers to address individual customer needs for technical support and connectivity. The first level, starting with the 24/7 care technical support from our global collaborative operation center network, complemented with ability to collect data on board and have remote connection to the vessel would there be a case that requires remote troubleshooting. On the level 2, we add an analytical layer. So first of all, the data is transferred from the vessel to our cloud infrastructure in close to real time automatically, so that the data is constantly available in our domain experts, which allows proactive troubleshooting and assistance, as well as analytics, may it be quarterly reporting or dashboards on the online tool. Then on the level 3, we are adding fleet intelligence, tailor-made dashboards, system security update service, which is ensuring the cybersecurity integrity on RDS equipment at all times through automated Microsoft updates and antivirus updates, as well as SMS and email notification also to the end customers. And then we have a range of optional services that can be added on these levels. Finally, on summarizing the customer value from our collaborative operations and remote diagnostic systems. So by collecting data with a high sampling rate and enabling remote troubleshooting through collaborative operations, we can increase the uptime while reducing the service cost. Immediate technical expertise and support is provided through assistance over a secured satellite connection from our collaborative operation centers across the globe. Monitoring equipment in a holistic manner enables holistic fault tracing of the entire system and finding the root cause of an electric and/or mechanical fault. Continuous data collection and online portal allow vessel and fleet level benchmarking to verify the operation of the equipment. And last but not least, the remote diagnostic system provides time-based reports and online real-time dashboards for detailed status overview of the equipment on board the vessel. That is actually the end of our presentation. We are actually right on time. So we have now 15 minutes reserved for questions and answers session. So while we start looking through the questions that you have posted, please also remember our upcoming webinars. There is a link on the screen. We have interesting seminars coming later this week on fuel cells. for example. So let's see if we can get some questions from the crowd.
Thank you, Jarkko. Thank you, Sti, and I can see quite a few questions here popping up. So let me pick directly one so we get cracking with this one. So how do you handle communication between the vessel and the onshore or cloud systems?
Yeah, maybe I can answer that, Anto. So ABB, we are using a remote access platform, which basically is installed on all the vessels with the remote diagnostic system. So this ensures the security standards that the industry is expecting. In short, basically it communicates only outbound from the vessels over a secure connection to the ABB cloud over port 443. And in addition to that, the control of the data flow or communication flow is in the hands of typically the chief engineer on board the vessel, meaning that the security policies for the RDS system is controlled by the chief engineer. For example, if an ABB engineer wants to connect to any given vessel, first of all, he has to go through two-factor authentication within the ABB corporate network. And on top of that, the chief engineer has to either approve a connection or set up a time limit, for example, between 12 and 2 o'clock on 1st of May, ABB engineers can connect to the system. So that's a well-tested and well-proven platform.
Great. Thank you, Sti. And to continue a bit on a similar subject, what are the bandwidth requirements for the remote connection, and do you use a continuous connection to shore at all times? There are quite a few questions relating to this one also. What amounts of data are you typically transferring from ship to cloud, and how much this is on daily basis, and does it affect also my satellite connectivity? So quite a few questions around this one.
Yeah, I can try to answer. First, to start with the bandwidth requirements and the system itself. So it's not a continuous communication flow going out from the rig. So how the system is configured as a standard, and this can be modified, of course, based on customer requirements. But as of today, we have a 10-minute interval on data packages going outbound from the vessel to the ABB cloud. So basically, there's a batch of data being sent from the vessel to the ABB cloud every 10 minutes. On the bandwidth requirements, we have stated that we require 512 kilobits per second, but of course this is only when a remote connection from an ABB engineer is required. We are trying not to utilize remote connectivity as we want to bring data out from the vessel so that we have easy access to data for our ABB engineers. But our requirement states 512, but we have installations with as low as 64 gigabits per second as well, which is functioning well. There's a quite advanced mechanism in queuing up data, queuing up these batch files going out on 10-minute intervals should the connectivity be down or some other technical issue, for example. So I think this answers the bandwidth and also the continuous mode. Maybe next question, Anto.
Yes, thanks, Diana. Then there is a question that what is the best way for me to get started with this remote technical support? And from ABB point of view, what are you thinking? Which system is the most critical? What should I approach first?
Well, naturally, it really depends on the vessel segment and the vessel type. So it's relatively hard to say what is the most critical system. Most importantly, that it's a platform, so you can start by monitoring one or few of the systems and equipment on board the vessel, and then later on extend the capabilities. So, for example, traditionally it might be that we are monitoring the electric propulsion chain, so azipods and propulsion drives. and then that could be extended to the switchboards or generators and motors. But it really depends on the vessel segment and vessel type.
Thank you, Jarkko. Then we have a question related to the software updates, how to keep the system updated, also regarding the cybersecurity topics. Do we have some solution for this one?
Yeah, Stian here again. Yes, we do have a automated service which enables antivirus and Microsoft patching of the ABB install base, meaning the Microsoft Windows-based industrial PCs. This can be embedded in one of the service levels that Jarkko went through. So yes, we do offer also cybersecurity related services in the RDS.
Excellent, thank you. Then about this, let's say, how to classify things question, what exactly is a critical trip notification? What does it mean? A threat, critical trip, or
yeah, so I can give
clarify.
Give a few examples. If we, for example, first take a propulsion drive or a propulsion frequency converter. So basically, our system, it combines different status signals from the frequency converter. So the RDS system is directly connected to the, let's say, the brain of the frequency converter. So basically, how we detect a critical trip is that we're looking at something called the main status word of the drive that indicates the status of the drive. Was it in off state, on state? Was it in ready ref state, which indicates that the capacitor bank is charged, or was it in running state, which indicates if the inverter was modulating or the motor was running, basically. So if it's in any of the ready ref state, meaning was the capacitor bank charged or was the motor running, and then it transists from that state into a tripped state, that is what we define as a critical trip for a frequency converter. And we apply the same logic also on the, let's say, the main switchboard, for example. You could give similar examples there. Was the main circuit breaker closed? Was it current flowing through the main circuit breaker? If yes, and then it goes into a trip state, then this is something that we classify as a critical trip. We want to some extent at least avoid, let's say, maintenance related false alarms that are occurring if the onboard crew is opening up doors, powering off circuit breakers, which is, let's say, related to planned activities. We don't want these notifications to take the attention away from the real critical incidents that might occur.
Excellent. Good clarification. Then a bit on the customer segments where we are present. There's a question that do you already have a reference customers in the cruise industry?
I may take this. So we do have several references in the cruise segment, as we pretty much have references across all the different segments. So I guess for this audience, the answer is simple: yes, multiple.
Thank you, Jarkko. Then regarding this process, so let's imagine there is a problem and let's say our engineers notice that a spare part is needed. So how do we deal with that? How does the process work for?
Yeah, so of course, yeah. Do you want to take this, Jarkko?
Yeah, well, I was just about to say that, of course, with the system, we're aiming to the situations where the spare part is not needed by a surprise. So, of course, we are aiming on proactively finding or maintaining the assets in a condition that they can be maintained by well in advance planned maneuvers. But in case that would happen, of course, we would then have the information already kind of in advance, since we are monitoring the equipment on live. So we would have the information and we could already internally start the process for dispatching or sending the spare parts. And Stian, if you have something to add, please.
I think that's spot on, Jarkko. And also just to add, I mean, we have these 40 different locations spread across the world, so we're also often quite near to most of the vessels. And of course, another aspect of having a remote diagnostic system is that we're also very capable of, let's say, finding the correct spare or finding the correct system defect or product defect, right? So it also enables us to make sure that whatever spare parts we are sending out, if that is the case, that we send, the correct spare parts, that we don't miss, that we think it's a semiconductor in an inverter unit while it was a measurement board, for example. So this is also capabilities on the spare part side that RDS helps with. And I would say to add also another aspect, if required, and sometimes it is required to send a service engineer on board, it applies the same there, that we're really well prepared when dispatching a service engineer to a vessel with the correct background information, and also sending a service engineer with the correct competencies.
Thank you, guys. Also, there is quite a few questions coming regarding this security of the remote connectivity, ensuring that and the data transfer, and is that possible to utilize to support online monitoring in the customer's own environment? So if you could answer this one. I think we covered a little bit, but maybe to repeat how we ensure that the connectivity is secure.
Yeah, so I think I mentioned, the process of having this two-factor authentication within the ABB corporate network, and that the security policies on board is fully controlled by the onboard crew. We also have cases where the customer would like to utilize the infrastructure to connect, and this is also functionality that we offer to the end customer, that the end customers can also utilize the ABB remote access platform to can connect remotely to their onboard vessels. It doesn't have to be the RDS system, but they can also basically connect to any Windows-based or Linux-based system on board if that's a requirement.
Thank you, Stian. How about sensor values and different this kind of devices? Can we monitor different sensors, and what kind of connectivity we have on board?
Yeah, out from let's say the ABB equipment that we have connectivity towards, we are supporting OPC DA, OPC UA, Modbus, TCP as the main communication protocols, meaning that if there is sensors, equipment, PLCs on board that supports any of these communication protocols, then RDS system can also collect data from that equipment.
Okay, we have a couple of minutes left, so let's look for one. So from the beginning, can ABB RDS support jackup rigs? ABB tries working in tandem with no software. Can RDS work in this case?
Absolutely. So we already have installed base towards that, let's say that type of installation. So again, the RDS system for a drilling system, it's connected to typically two main components. One is the ABB control system, and the other one is the main brain, the RMIO board, or the AMC board of the frequency converter. So I believe also in the case that is described here for NOV cases, we still have the RMIO controllers for the frequency converter, so RDS can be connected to those drives as well. Yes.
All right, great. Thank you, Stian, and thanks for everybody joining. A lot of questions. Let's continue on those specific questions on separate private sessions that we can arrange separately with you. Thanks thanks a lot for participating.
Thank you also on my behalf to everybody.
Yep, same for me. Thank you very much for attending.
Thank you and goodbye.